This is the question. I will explain you the points which are important in the question. पहली बात, the stress strain diagram, इसका मतलब he wants to say this is engineering stress strain diagram. Stressed up to 600 megapascal means it has crossed the elastic region. So if it is released, इसका meaning if it is released, then there will be a plastic recovery. Sorry, there will be a plastic non-recovery plus some elastic recovery. So total strain in the body is equal to elastic strain plus plastic strain. So if we leave the body here, it comes down here. So this CD is elastic recovery and OC is plastic non-recovery. And what values you will get here are engineering strain values. Now in this particular question, the important thing is this is made of the same aluminum. So the curve, engineering stress strain curve, has a special ability that for the same material, whatever be the length and whatever be the diameter, it remains the same. So you can use this exact graph even for AB portion and even for BC portion alone. So total elongation in the body is equal to elongation in AB plus elongation in BC. So this was the main point here, and these are engineering stress strain curve. If we take up to elastic, then you just think the solution is there. एंड इम्पॉर्टेंट पॉइंट इज मेटल फॉर्मिंग में हमने लोड लगाने के बाद भी वॉल्यूम कांस्टेंट लिया था, बट वाई इसका मतलब वॉल्यूमेट्रिक स्ट्रेन ज़ीरो है. सो मतलब वॉल्यूमेट्रिक स्ट्रेन मीन चेंज इन वॉल्यूम का मीनिंग डेंसिटी में चेंज होना पड़ेगा. बट द थिंग इन SOM इज in SOM there is a plastic volumetric strain. There is a volumetric strain. I repeat all the statements. There is a volumetric strain. इलास्टिक लोड अगर लगेगा तो उसमें वॉल्यूमेट्रिक स्ट्रेन आएगी, क्योंकि प्लास्टिक रीजन में फ्लो ऑफ मटेरियल होने लगता है, इसकी वजह से वॉल्यूम कंपनसेट हो जाता है फिर से. बट इन इलास्टिक लोड देयर इज अ थिंग कॉल्ड वॉल्यूमेट्रिक स्ट्रेन. सो वॉल्यूमेट्रिक स्ट्रेन कॉन्सेप्ट इज ओनली डिफाइंड up to elastic limit. So suppose this is the initial case जिसका वॉल्यूम है ये, और this becomes the final case after applying load. If this load is within elastic limit, so you cannot say that volume 2 is equal to volume 1. So if only df is given in this, so you cannot find lf because you cannot equate both this and find lf. For if df was only given, to find lf there is a thing called Poisson ratio. That's why there is a thing called Poisson ratio up to elastic limit, which is only valid up to elastic limit. And due to thermal load, thermal is also up to elastic, so any elastic load, so of course also due to thermal loading there is volumetric strain, which we study. Rolling, forging, all this deal in plastic region. So in plastic region, due to flow of material, there is volume constancy. So that why L is equal to AF LF in metal forming. But you cannot use volume is equal to constant in strength of materials, because elastic loading is mostly preferred in SOM and volume is not constant in elastic loading.